For today's lesson, we will be discussing function operations and composition. But before we get started, we must go over a few definitions. Function. A function is defined as a relation between a set of inputs having one output each. For example, we have f of x. And another example you can think of is such as a table graph or a table just full of data that you have to interpret to get f of x or g of x. A composition function. Values found from two given functions. This includes this little circle you see right here that's just like a little tiny O, which just stands for operations. And you have f of operation g of x. And then you have your, you have to find the values based off those two functions. Different quotients, the slope of a secant line formula. The slope would be the point that passes through a curve. Now that we understand some of the important definitions for this lesson, we will continue. For example number 1, we have f of x equals 5x plus 4, and g of x equals 4x minus 7. And to figure out the answers, we have 4 solutions: the sum, difference, product, and quotient. To figure out the sum of these two functions, it would be parentheses f plus g of x equals our answer. So let's write that down. 5x plus 4 plus 4x minus 7. And then we simplify and we get 9x minus 3. And that would be our answer since there's no further way to simplify it down. Since our variable isn't included in a square root, the domain will be all real numbers, or negative infinity to infinity. Next up, we must solve for the difference. This is parentheses f minus g of x is equal to our answer. So let's get started. F of x plus 4, and since we're subtracting by g of x, we must include it in parentheses to manipulate our answer into getting the correct one. So then we simplify. This becomes negative 4x, and this becomes positive 7. Then we simplify, we get x plus 11, which is our answer. And again, our variable isn't in any type of square root, so our domain will also be all real numbers. For the product, we have f multiplied of g of x, or by g of x, equals our answer. To write this down, we would write it such as parentheses f of x plus 4 multiplied by 4 of x minus 7. You could also include these in parentheses, but it is considered unnecessary, but I like to include it. Next up, we put the values, or at least in the first parentheses, into each one. So for example, 5 of x times 4 of x equals 20x squared. 5 of x times negative 7 equals negative 25, 30, 35. X. 4 times 4x equals 16x. 4 times negative 7 equals negative 28. Now we simplify. Let's add our little equal sign. We still keep 20x squared. And this becomes negative 19x minus 28. And this is our answer. And because our variable isn't in any type of square root, the domain will always be all real numbers. Now for the quotient. The quotient will be parentheses f over g of x. And we'd write it down such as this. Now, like many of our previous answers, there is no way to simplify, but we still need to find the domain. And as you know, this is equal to y over x, and the domain is the perimeter of x. So we do not necessarily need to focus on this, but we do need to write it down as our solution. But for our domain, we can forget about this and focus on 4 of x minus 7. Recall from the previous lecture, anything on a denominator will be non-inclusive, such as the infinities. And we can also set it to 0. So let's solve. 4x minus 7 equals 0. Plus 7, 4x equals 7, and divide by 4, and you get x equals 7, 4. Now, since the variable is not in a square root, we have to exclude 7 over 4 since it is not inclusive. And how would you do that? Well, we do not have enough space. So we'll just write the domain right here. To not include it, you would write the same as this, but instead, you will have 7 over 4 as the greatest value, and 7 over 4 as the least value. Oh, sorry for the handwriting, but that would be our domain. For example number 2, we are given a data table of x, or the domain, function f of x, and function g of x. And here is the expressions we need to find these solutions to. For our first one, we have a product rule, f plus g of x, but then instead of x, we have 3. What this means is that x will be 3. Luckily, they gave us a data table. So all we have to do is look where x is 3, and these are our values. So f plus g of x, where 3 is at, that's simply 10 plus, but since this is just a negative, so our answer would be 7. Next up, we have f minus g of x, that is 6. So we go to 6, and we have 13 minus 7, which equals to 6. So our solution will be 6. Next up, we have a product rule where f is multiplied by g of x, that is negative 3. We go to negative 3, and we have the value of 0 multiplied by 4 equals, 0. Now for our last solution, we have f over g of x, where it's 0. We go to x, where it equals to 0, and we have 7 as our f of x, and we have 0 as our denominator. Now, as you know, if 0 is the denominator, then the solution is undefined. So then we'd put that as our answer. And now we have solved all of our solutions. All right, for question number 3, we have f of x equals 10x squared plus 10x plus 4, and it wants us to find the difference quotient. As you can recall from the definitions part of the video, the difference quotient is the line that passes through a curve. Here we have a slope because it has m equals, and here's our slope formula for the difference quotient. F of x plus h minus f of x all over h. So how do we plug this equation into the formula? Well, as you can see here, f of x plus h. This only applies to the numbers that have variables. So we have one number that has a variable and another has a variable. But we have one of these. So how will we write this for 2? Equals, take out the 10, keep in the x plus h, and since this x is squared, we include like this, then we do plus 10x plus h, this one does not need a square, plus 4. And we also need to include minus f of x. And if you recall, if you have a minus, let's see, you must manipulate it by including everything else in parentheses. This is a long problem, but it's just, or mostly, simplifying. Next up, we must figure out what x plus h to the square is. Next up, we need to solve to see what x plus h to the squared is. We'll set x plus h to multiply by itself, because this is what x plus h to the squared is. So then, you put your values into the other side, and you end up with x squared plus xh plus xh plus h squared, which simplifies to x squared plus 2xh plus h squared. Now that we have the equation for x plus h to the power of 2, we can now solve. So we just multiply this by 10, which gives us 10x squared plus 20xh plus 10h squared. And then we also do the same, plus 10x plus 10h plus 4, and we multiply everything by negative, minus 10x squared minus 10x minus 4, and all of this is all over h. Now, do not be intimidated, because now we can simplify. So I will underline all of our values to make this process a lot easier to see. So how can we simplify? Well, I see a plus 4 and a negative 4, so those obviously cancel out. And I see a negative 10x squared and a positive 10x squared. So these cancel out. I also see a negative 10x and a positive 10x. So we can take these out. Now that we have simplified, we are left with this answer. So how can we further simplify? Well, I see an h on the bottom and I see h's up here. So all we need to do is factor out an h. How would you do that? H on the outside, have your parentheses, and this just becomes 10h plus 20x plus 10. And then these h's cancel out and we're left with our answer, which is 10h plus 20x plus 10. For question number 4, we are finding a composite of f of x equals 4x minus 1, h of x equals negative x plus 1. So what is a composite? Composite is two functions, and you're going to find the value by setting them close to equal to each other. So this one, we have negative 1. So instead of having them on each side, you just have f, and f's x will be h of x. And h of x is set to negative 1. So something like this. So how will we start? Well, we go to h of x first. And instead of x, you put negative 1. And wherever you see your x, keep the negative and you set it to negative 1 plus 2. This equals to 1 plus 2, which equals to 3. H of negative 1 just becomes 3. So f's x becomes 3 as well. And you set anything where you see x equal to 3. And we're left with 12 minus 1 equals 11. And this is our answer. For question number 5, we deal with another problem that uses composite functions. Here we have f of x equals the square root of x, and g of x equals x plus 9. For solution A, we have f of gx. This, in short, is just f, where its x is replaced with g of x. So, let's see, we have g of x, which equals x plus 9, and we would just replace it for that x. So this will look like the square root of x plus 9. Now, that is your solution. However, the solution also wants us to find the domain. So our solution is the square root of x plus 9. But how do we get the domain? Well, we know that the domain will always be a positive and inclusive. So it would likely be a value to infinity, which is not inclusive. Now, what is this value and how do we figure it out? Well, we can take out x plus 9, set it equal to 0. And we know that since x and 9 always get interact, we're going to get a value of this. X equals -9. So we include -9, and the domain could be any of these values. Now, for solution B, we have g of f of x, and we would write it as g, where its x is just f of x. So whatever value we have for f of x, which is the square root of x, we swap it for this value. So let's add the equal sign. We are left with x, or the square root of x plus 9. Now, for x, we do not need to figure out the domains by saying it equal to 0. Instead, we know that x is just by itself because plus 9 is not included like this solution is. So, as I said last time, we are just going to be left with 0 since it's a square root to infinity. And let's also write our answer here. And that is how you solve this solution. For example number 6, we have another composite functions. We have f of x equals 9x minus 3 and g of x equals 1/9 multiplied by x plus 3. And for solution A, we're finding the composite of f of x where its x is g of x. So let's write that down. We got f of g of x. So we would put g of x to where any value is x. But first, I believe we should solve this. So let's see. Let's rewrite it. 1/9 multiplied by x plus 3. And we get 1/9 x. And we multiply this and we get, see, positive 1/3. So now we can plug this value into x, which gives us 9 over, or multiplied by 1/9 x plus 1/3 minus 3. 9 multiplied by this just becomes 9/9, or, 1x plus 9/3, which is just 3, but it gets canceled out by the other 3. And we are left with 1x, or simply x. Next up, we're going to do the same operation, but instead, g is f of x, or g's x is f of x. So let's see. Okay, so we could just rewrite it because we don't need to further simplify. So we put 1/9, 9x minus 3 plus 3. These cancel out, and 1/9 times 9 equals 1/x, which is just x. So this also equals x, so these solutions are equal to each other, and that is the end of our examples.